Doppler effect with light. Consider a source of light, such as a star, being observed from the Earth. A star emits electromagnetic radiation of a wide frequency range, which travels through space at c, the speed of light in a vacuum. We saw in grade 10 that the electromagnetic spectrum is a range of frequencies of electromagnetic radiation from gamma rays to radio waves. Visible light is a tiny part of the electromagnetic spectrum. Visible light is composed of various colors of light, from violet to red. The red end of the visible spectrum corresponds to lower frequency, and the blue end to higher frequency. We shall understand the concept of Doppler effect with visible light and extend it to the other types of EM radiation. Let us assume that this particular star emits green light. Let us further assume that the star is stationary. The wavefront of the radiation emitted by the star will reach the Earth after traveling through space after a certain time. Depending on the frequency of radiation, the light will be perceived to be of a certain color. The green light emitted by the star will be perceived as green light by an observer on Earth. There is no relative motion between the source and the observer. Now, consider a case where the same star is moving away from the Earth at a speed of 0.25 c, that is 1/4 the speed of light. The first wavefront of light from the star will reach the Earth at the exact same time as the first wavefront of light in the first case, when the star was stationary. The subsequent wavefronts of light emitted by the star in the second case will have to travel greater distances through space. Therefore, the perceived wavelength will be greater than the wavelength of light perceived in the first case. Notice the frequency of the light. That is, the number of cycles in the same length of time has reduced. So, the observer on Earth will see a decrease in frequency of the perceived light, and the green light will appear red. This is called red shift. If, however, the star is moving towards the Earth, the wavefronts will have to travel lesser and lesser distances to reach the Earth. This results in a reduced perceived wavelength of light by an observer, and an increased perceived frequency. The green light will appear blue or violet. This is called blue shift. It is important to note that the star emits the same wavelength of light, that is green, in all cases. It is the perceived wavelength that is different in the latter two cases. In reality, any star emits electromagnetic radiation of a wide frequency range. The radiation is usually beyond the visible light range, such as infrared or ultraviolet light, or even microwaves or gamma rays. But the term red shift is used for radiation shifting towards a higher wavelength, and blue shift for radiation shifting towards a lower wavelength.
Starting to feel it? Now go master it with Maski.